This is lesson 11:6, areas of parallelograms, triangles, and trapezoids. We're going to start with a parallelogram. It's a pretty basic figure. The definition of a parallelogram is that opposite sides are parallel. On a parallelogram, you have a base and a height very similar to a rectangle. One thing you need to notice, the height of the parallelogram is not a side. The height is a perpendicular distance inside the parallelogram. The way that you can tell that it's the height is you always see this right angle. That makes you realize that it's the height because height is measured only at a right angle, at an altitude. So the area of a parallelogram, once you get that height figured out, it's the same formula for the area of a rectangle. It is taking the base times the height. Occasionally what they're going to do is they're going to throw in other segments. They might give you this measurement over here, this measurement over here, and then let you decide that you really have to use this as the height. Don't use anything else. Alright, so let's look at our first picture. Using the example and talking about what I just said, example 1, we have to find the area of that parallelogram. They've given us 3 measurements. So I'm looking for that right angle right off the bat. That means that 6.2 is going to be considered my height. And since it's drawn to the left-right sides, then the 4.3 must be my base. The 8 plus 8.3 is just additional information that I do not want to even look at. So what I'm going to suggest for all these formulas and area problems is that you do write the formula. That way maybe you'll help get memorized of what it is. So the formula for area of a parallelogram, you would write A equals B times H. Then I'm going to have you fill the numbers in. So please do not eliminate that first step. I want you to write the formula on every problem. So I'm going to now substitute in, and instead of the dot for times, I'm going to use parentheses because there's decimals in my numbers. So for base, I'm going to add 4.3, and for height, I'm going to plug in 6.2. Now the area of 4.3 times 6.2 would make this 26.66, and 26.66, I'm going to recommend that we round to the nearest tenth on all of these. So it's going to be 26 point, and you always have to look at the hundredths place to figure out where to round your tenths, and the 6 is 5 or higher, so we'd put 26.7, and then you must do inches squared. Please do not put that square on the 26.7 because that would be wrong. 26.7 inches squared would be the area of that parallelogram. Now we're going to look at triangles. Triangles could come 3 different ways, so I want to make sure I cover all 3 ways for you, so whatever you're presented with, you're prepared. First of all, if you're given a right triangle, the base and height are just the legs. Those are the 2 sides that come together to form the right angle. So you're looking for the lengths of those sides for a right triangle. For an acute triangle, the base is out here, but the height's going to be somewhere inside, and you're always looking for that right angle, and that makes sure that box, you know it is the height. And finally, obtuse. Well, obtuse is kind of a weird one because the height is actually outside of the obtuse triangle itself. Here's my base. To get the height, you have to extend this side. That's called an auxiliary line, an imaginary line that's really not there. And from the opposite vertex, you drop that height. And that is what you consider the height of the triangle, that segment outside of the triangle itself. That's going to happen if you get an obtuse triangle. No matter which of the types of triangles you get, the formula is the same. Some people say area is 1/2 times base times height. Or another way to look at it, if it's easier for some of you, area would be base times height divided by 2. That is equivalent. You could do it either way. Either way you choose, I don't care, but I want you to write one of those down on all the problems. All right, so I'm looking at this and I see example 2. It looks like I have an acute triangle. I've got a base of 22 and a height of 25 centimeters. So I'm going to write the formula and I'm going to say area is 1/2 times base times height. Remember, I told you you could use the other one if you prefer. Now I'm going to fill the numbers in. Area is 1/2 times 22 times 25. Okay, you could go ahead and multiply 22 times 25 and take half of that, but I'm going to go ahead and multiply left to right, and 1/2 times 22 I know is 11, and now I've got to take 25 times 11, and when I do that I get 275. And I have to just make sure that I write that in units squared, so centimeters squared. Area is always labeled in square units. So area of a triangle, 1/2 times base times height. All right, let's look ahead to a trapezoid. In this trapezoid, it's kind of light, but let me show you the important parts of a trapezoid. The two sides that are parallel are known as the bases, and this one up here is labeled base 1, while the one at the bottom is labeled base 2. And there we've got this right angle again. That is indicating my height on the inside is that distance between these two parallel sides. The two bases, that perpendicular distance between them is considered the height. The formula for area of a trapezoid, I'm going to write it here because it seems like it's very light, 1/2 times the height times base 1 plus base 2. Now, it's kind of similar to the triangle formula because it's 1/2 base times height, but since there are two bases in a trapezoid, you have to add the two bases first and then proceed with the problem. That's why they're in parentheses, so that's what happens. All right, let's look at example 3. I have a height, I can't hardly read it, it looks like a 6. This base is 5.5 meters, and this base is 7.5 meters. So this one's a little more complicated than the rest, so it takes a little more time. I'm going to write my formula. Area is 1/2 times height times base 1 plus base 2. Fill in the appropriate numbers in the right spots. So the height is 6. And then base 1 plus base 2, I've got to write 5.5 plus 7.5. Well, I'm going to go ahead and follow PEMDAS on this, and I'm going to do inside the parentheses first. And 5.5 plus 7.5, well, 5 plus 7 is 12, and then I've got 2 halves, so that's going to make that 13. Now I'm going to go ahead and multiply from left to right, so 1/2 times 6 gives me 3. 3 times 13, whoops, I made an extra 1 there. 3 times 13 is 39. So my area formula, or my area for that trapezoid would be 39 meters squared. A few more steps in trapezoids that you've got to make sure you do inside your parentheses first and then multiply. All right, I'm going to go on now and I'm going to look at something where they give me the area and I have to work backwards maybe to figure out what's missing. So I've got a triangle and I know the area is 44 meters squared. That's really important that I know that. And it tells me that I know the height already. It's 8, but I don't know the base length. So like all of the others, I'm going to insist that you write the formula. A equals 1/2 base times height. But when I fill numbers in this time, I'm actually filling a number in for A, area. It is 44 and 1/2 base, and the height is 8. Okay, well, here's what I would do with this. Over here on the right, it looks a little complicated. It's got a B in the middle of it, but those are three things being multiplied together. So there is nothing wrong with me taking and saying, I want to go ahead and take 1/2 times the 8. And 1/2 of 8 would be 4, and I've got 4B. Now I'm going to divide by 4, and B equals 11. Now this is not an area, this is just a length, so it will not be units squared, but it will be 11 meters. So you take the formula and you plug in the numbers they've given you and you solve for what's missing. You've done this lots of times in multi-step equations, way more complicated than this, so please just take your time, fill in the appropriate number in the correct spot, and you should be able to solve these. Make sure areas are labeled square units, and then the ones that are just lengths or missing lengths of sides, it's just the unit that they've given you for the other measurement. It's not square units.